Well, Adam, do we have everything we need here for this experiment?
I think we do. We've got the acid, we've got the salt, we've got the voltage meter for testing salinity, thermometer, and perhaps most importantly, in fact, without this we couldn't do the experiment, we have our test subjects here, our frog eggs.
With the octopus angle ruled out, they have opted for frogs' eggs and tadpoles, small and common enough in nature to be swallowed, and they don't need constant parental care.
Yeah, those puppies came all the way from Florida. They have a lot of frog farms down there, I understand.
3 flasks represent different conditions in the stomach. One for body temperature, water heated to 98.6. One of salt water, the same salinity as the human body. A third with a pH of 2 contains acid, imitating human stomach juices. A 4th flask is the control sample.
All right, so we got some tadpoles and some eggs in there. Let's say we do 2 of each.
Okay, you got the little squirt bulb?
I do. Here we go.
The control sample of eggs and tadpoles will swim in a flask of aerated water, the ideal environment for tadpole survival.
You ready for the acidity?
Okay.
Okay, which one is that? Acid, this one here.
Hydrochloric acid actually secretes in the stomach, and it's powerful stuff. Extremely corrosive. A single drop can eat through wood. Jamie and Adam need to dilute their pure hydrochloric to match stomach acidity.
Yeah, real close.
All right.
1.99. All right.
The pH scale runs from 0 to 14. Pure water is neutral with a pH of 7. Anything below 7 is acid, and anything above is alkaline. Common examples range from battery acid at 1, the stomach at 2, an apple scores a pH of 4, and milk of magnesia a mild 10.5.
Doesn't seem to be doing so hot. He's definitely more laconic than his racetrack friends here, you know. He's just kind of sitting there on the top.
Next, the body temperature test. They heat water to 98.6 degrees Fahrenheit.
Okay, here we go. He's not, you know, doing a racetrack thing like his brethren down here in the Pyrex.
For the next phase of the experiment, Adam's making a personal contribution.
Here we go.
What Adam's doing is measuring the electrical conductivity of his saliva. Now, we're going to try and replicate that conductivity in water by adding salt to it.
Electrical resistance is the best way to determine salinity because dissolved salts are strong conductors. In Adam's mouth, the resistance is low, measuring around 4 kiloohms.
There's one. He's doing pretty good.
No, he's actually doing fine.
Here's another. Salinity, they both seem to be doing okay, so we should leave this overnight and see how it does.
Yeah.
Tadpoles might find it tough going in the stomach, but are there any life forms tailored to the conditions?
Come down here, I got some worms all set for you.
If anyone knows about creatures surviving in the human stomach, it's Dr. Jim McCarrow from the University of California at San Francisco. As a professor of pathology, he's heard all the stories.
Why would it not be possible for a thing like an octopus or a snake to grow and develop in your body?
The acid in your stomach is there to dissolve meat and other food materials, and any type of living organism that doesn't have a way to protect itself against that is going to just wind up as digested food.
So are there creatures that do have that type of protection that can make it through the acid in the stomach?
Oh, most certainly. Tapeworms, for example, which are a type of parasite that you get from eating undercooked pork or beef. Also, certain types of roundworms, where in this case it's the egg of the worm that makes it through and then hatches in your intestine. And in both of those cases, the reason that they can actually make it through the gastric acid is that they're coated with a very hard shell. It's called a cuticle, and it's about as hard as your fingernail. So by having this, basically this armor on its surface, these worms can make it through the gastric acid, get into the small intestine, and basically live in paradise because they have as much food as they want to eat.
In the United States between 1900 and 1920, tapeworms were being advertised for weight loss. Each segment of the worm was sold individually with claims like no ill effects and easily swallowed. Today, worldwide, about 1 billion people are infected with parasitic worms, particularly in tropical regions.
You know, with things this big and this prevalent, it's not surprising that a lot of stories probably evolved because people were seeing these things in their environment all the time, and they probably attained mythical proportions.
When you look at these, the leap to an octopus doesn't seem like that great a leap.
Sure, I mean, and imagine these all bunched together. You know, it would be like a Medusa head. And they'd often be passed by a child that way, so you actually would see something that looks like a Medusa head lying in the crib.
That must be it. What do you think?
I think no pasta for lunch. All right, Jamie, it's been 3 days. How are our frogs doing?
Well, most of them are still alive. You know, the control group is great. They're happy little tadpoles swimming away in there.
They look even bigger than they were a couple days ago.
I believe they have grown a little bit. And the saltwater seems to be fine with them.
Yeah, they're
you know,
still going.
they're doing just as well as the control group, actually.
What were the killers?
The real killers were the acid and the high temperature.
Well, that killed them each in like 10 or 15 minutes, didn't it?
Pretty much, yeah.